Welcome to this review of relative value methods. Of course, here we're spread trading. We're looking to go long things that we think are going to go up, short things that aren't going to go up as much or even go down. As long as they converge, then our trade works. I mean, they can go up and converge. The long will go up more than the short. They could go down and converge. The short will go down more than the long. As long as convergence occurs, we're fine with that, because it's really this mispricing, temporary mispricing, that we're exploiting, because these assets need to be related or even pretty much economically the same thing. So how do we identify relationships between assets? Well, the natural tool to use would be correlation. It's quite a simple tool though, correlation. A more sophisticated tool is co-integration. Let's have a look at part one here. Is this a correct definition of co-integration? Co-integration occurs when a linear combination of the logarithm of two stock prices is a stationary process over time. That looks okay to me. You know, if we can take the logarithm of two prices, linearly combine them, and that behaves itself as a stationary process over time, what it means, you've got a mean reverting process, constant mean, constant variance, and you know when that is going to mean revert. So for example, if you took stock A and stock B, you took the logarithm of those prices and you found that, say, 3 lots of the logarithm of A minus a half the logarithm of B was a stable process. What you're really saying is, it's random, but there's a constant mean and a constant variance. So actually, you know when it's high and you know when it's low. There's the mean there, and the variance is setting the width of this corridor, right? The standard deviation of variance is setting the width of that corridor. So you know when it's high and you know when it's low. So you can trade this relationship. That's a good definition of co-integration. And it explains why, you know, having this stationary process, even though it's random, you know it's going to mean revert, so you know when it's high and when it's low, so you can trade it. So one's fine, so I'm not going to pick anything without one in, so we rule out C. Part two here, the crack spread is executed through buying crude oil futures and selling futures relating to the outputs of the refining process. So we turn crude oil into all sorts of distillates, as it's called. But this looks fine to me for the definition of a crack spread. Classic crack spread actually is buying crude inputs and selling heating oil and natural gas in a ratio that will be given to you if you're asked about it. This, you know, obviously natural gas and heating oil are outputs of the crude refinery process. The idea is this spread allows oil refiners to hedge their commodity margins, because they can buy futures which hedge them against their input costs going up. They can sell futures which lock in their revenues and hedge against the output prices going down. So 2 looks good to me as well. I won't pick anything without 2 in it, so I don't pick D. So the question becomes, is 4 correct or not? We're never going to pick 3. All right. The reason we don't pick 3 is a location spread with each side having the same delivery date. That's not an arbitrage, because an arbitrage would involve taking delivery in one market, the first market that you take, you buy in the first market, you take delivery cheaply, then you transport it to a second market and you deliver the commodity out under a short forward position. You need time to transport the commodity, so having the same delivery date, it's not a pure arbitrage. Or it's not a type of arbitrage trade here. It's actually a correlation trade. If you've got the same delivery date, what you're really doing is just playing the correlation between 2 contracts with the same delivery date. You're not actually playing an arbitrage between taking delivery in one market and delivering out in another market where you've sold forward. So that's a correlation trade. That's why we don't pick 3. 4, do we pick it? It's a relatively straightforward one. Noise traders can cause losses to relative value traders. That's one of the first things that gets mentioned when we talk about risks to relative value